Okay, this is Fred, chapter 12, Pi 1. Yay! Hello, this is Stanley Anthony, the pizza guy. And Stanley says, "Welcome, Fred. Welcome, Betty and Alex. Welcome." Stanley Anthony is a longer name. It has 5 syllables. Stanley Anthony. 5 syllables. Over the years, some people have called him Stanthony. That would be spelled like this. All one word. That's a strange word. That's just 4 syllables. Stananthony. And then they shortened it to 3 syllables. Stanthony. Stanthony. He was happy with any of these names. He would say, "You can just call me any name you want as long as you like my pizza." Now, when Stanthony was born, his name was Ed Lee. He was the great-great-great-grandson of Robert E. Lee, who was the general who commanded the Army of the Confederate States of America during the last 3 years of the Civil War. Years ago, when Ed Lee started Pi 1, he changed his name to Stanley Anthony Michelangelo di Lodovico Bernardo Simino. He thought it sounded more Italian. It just sounds like a really, really long name. Now, he had chosen Stanley Anthony because it rhymed. Stanley Anthony. The rest of that whole long name he took from encyclopedia. Now, Stanley told Fred, "Your big green ice cream machine was delivered this afternoon, and it fits perfectly in the alcove in the back of the building." Now, I couldn't find a big green ice cream machine, so I decided Big Green Kermit would do instead. This is a map of Pi 1. We have right here, this is where the people would eat, right here. And we have some dimensions, which I'll come over and show you. That's what these numbers are. So I'll come back to this. This right here, this green area, is Fred's ice cream machine. Now, Stanley says, "That's a lovely, beautiful green machine. I only have one question. What is it?" Fred says, "It's an ice cream machine," and that he was going to use it in his talk this afternoon at the Math and Pizza Conference. "But it's so big," Fred says. Fred says, yes, that's why he picked it out, because he needs to make lots of ice cream. Stanley says, "But why is it green?" Fred said he had the choice of 5 colors. You remember that lesson? We had red, we had blue, we had brown, we had yellow, or we had green. And he picked green because it was the color, and wait for this is just perfect. He picked green because it's the color of grass that one-eyed Bessie likes to eat. Oh, how more perfect can you get? Stanley wants to know, how does the machine work? Fred's answer is, "I don't know. I've never worked an ice cream machine." "Well, okay," says Stanley, "but I have a question for you. I want to string a whole line of Christmas lights all around the outside of Pi 1, and I need the perimeter of the building so I can order the right length. When you look at my map, I have some missing numbers. Would you come outside and hold one end of my tape measure?" Fred's like, "Christmas lights? This is February. Aren't we rushing things a little bit?" But Fred looked at the map. So Fred looks at the map, and he sees that there are some numbers that he doesn't know what the distance is. For example, we have an X here. We have a Y here, and we have a little X there. We have a 40, we have a 17 for this bit right here. We have a 7 for this little bit, an 8 for this, and an x right here, and a 5 here. In algebra, we know that letters like this, wait a minute, this is wrong, hang on. Oops. This one should be a Z, not an X. Sorry about that. So, because we have an X right here. Okay, so we have X, we have Z, we have Y. Those in algebra are considered unknowns. We have to figure out what that number is. Now, Fred would have been happy to help Stanley do the measuring, but there was an easier way. He could use mental thought instead of having to go around and measure. For example, Fred knew that X, which, hang on, let me get a different color here, that X, which is right here, would have to be the same as the 7, because it's opposite sides, and the opposite sides are going to be equal. So we know that X is going to equal 7. Now, that means that we have, if we add up the other numbers, we can add up the 17 plus the 8 plus the 5. So we're looking at the 17 right here, the 8 right here, and the 5 right here. We can total that up, and that will be 30. And so we know that this Z right here is going to be equal to these sides. So 17 plus 8 plus 5 is 30, and so Z equals 30. Okay. So I just want to go over that again and make sure that you got that. So we don't know what Z is, but we know on this side we had these numbers. 17, we have this edge right here, which was 8, and this bit down here, which was 5, and this bit up here, which is 17. We added the 17 plus 8 plus 5, and that equals Z, because this side is going to be the same measurement as these three combined, okay? Which was 30. If we look at how we got, let me erase this. It doesn't erase very fast, so you can sing to yourself for a minute. Okay. Oh, I erased more than I wanted to. Then on the other example, we had X here and 7 here, and we know that this line is the same as this line for a triangle, so X equals 7. So that was easy to use mental math to figure out our dimensions. Now, let's suppose you had a bunch of cows, which is what Jordan has. So let's scroll down and see what a bunch of cows look like. I don't know. Can you figure out which one is Bessie? So let's say that Jordan had 23 cows in the west field. Okay. And she had 18 cows in the east field. Okay. Now, Jordan could go around and she could count each cow all the way up to add them up. She could do 23, 24, 25, 26. She could count them all, and she would get to 41. Or, instead of counting each cow one by one by one by one by one, she could add these together and also get 41. Okay? Whenever you want to get a total, of two things or two groups or whatever, you add them together, okay? So, guess what? Okay, it's your turn to play, so let's see what we got today. Okay, let's suppose that you are 2 years old. Okay, and you had 7 boxes of chocolate drops. Okay, you can have 7 boxes, and each box contains 3 chocolate drops. It looks like this baby has already eaten all those, but we'll deal with that in a little bit. And you wanted to find out how many drops you had all together. You could break open the box like the baby clearly did, and you could count them one by one by one. So let's see what that would look like. So if I open 7 boxes, so I have 1 box, 2 box, 3 box, 4 box, 5 box, 6 box, and 7 box, and each one has 3 gumdrops. So I could count my gumdrops by going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's a 10, but it won't write right. 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so this is 7 boxes and 3 chocolate drops in each box, and I counted all the way to 21. Now, let's say now that you are 4 years old and you know a little bit more about math. You could just add up the boxes. So we had 1, 2, 3, 4, 5, 6, 7 boxes. We had 3 in each one, so we could go 3, 3, 3, 3, 3, 3, and 3. Or we could add this up as we go. 3 plus 3 is 6, plus another 3 is 9, plus another 3 is 12, 15, 18, 21. So what that looked like was sorry, let me erase that. Was 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. Okay? Now, which way do you think would be the easiest? To count them 1, 2, 3 all the way to 21? Or to add them together? Or I bet you could think of another way. We could also multiply 7 times 3, and we would get 21. So we talked about counting them one by one, grouping them and counting them in 3s, or multiplying 3 times 7 and getting 21. Now I want you to create a problem like I just showed you. I don't care, you can use any numbers, but figure out a problem that includes so many boxes, so you can choose how many boxes, and you can choose what is inside those, what's inside it, and how many pieces, and then I want you to work that out, showing me if you add it together, if you count it all the way up, or if you multiply it. Show me how you could do that. Okay? If you're confused, then ask me, and I'll tell you again. But basically, you're recreating the problem I just showed you with the 7 and 3, but you're using a different number of boxes or sacks and a different amount that's in in each box. Okay. Now, question number 2 is going to be about perimeter. It's what does the outsides measure so we can know how big the building is. In pi 1, so to figure out the perimeter of pi 1, we've got to add up all the outside pieces. So we have 30 here, we have 40, we have 17, we have 7, we have 8, we have 7, we have 5, and we have another 40. So write down these numbers: 30, 40, 17, 7, 8, 7, 50, and 40. And then I want you to add all those numbers up again. Remember, if adding up this way is difficult, you can break it down and add two numbers together, and then keep adding until you get down to one number. However it works. If you have a problem, ask me about it, okay? Question number 3 is about carpet. And Stanley wants to install new carpet. What is the area of the floor inside pi 1? Okay? What is the area of the floor inside pi 1? Okay, so now we want to look at the area, because area is what's going to be the area inside our rectangle box here, and it's length times width. So in the big triangle, which is the outside here, it's the big one here, we know that it's 30 on this side, and this one added up here to be 30. So we can call that our length. If my pen will work. And then we have this here, we have 40. And so it's 30 times 40. Now to get area, and you don't do 30 and 30 and 40 and 40. We're just taking one length and one width, okay? Just one of them. 130, 140. And that will give us the size of the large triangle. So on a piece of paper, I want you to write area equals L times W. That's area equals length times width. And I already wrote the numbers down here. And you can solve this. And this is, right now I gave you, this is for the big triangle. I mean the big rectangle. Now we have to figure out the area for the small one, which is this one right here. And that area, it's going to be the same thing, because we know that it's 7 and 7 and 8 and 8, but we only need one length times one width. So it'll be, we would have 7, and the width is 8, and so it's area is going to equal 7 times 8, and get an answer there. So on your piece of paper for number 3, you'll have this equation, which is area equals L times W, and that's 30 times 40, and then the formula for the small triangle, which is again area equals length times width, and that was 7 times 8, and solve that one. And then you have to add everything together. So you're going to have this answer is going to go right here. You're going to add that with this answer right here, and that will give you the total area. Okay, so see if you can figure that out on your piece of paper. Okay, next we have skills practice. You will have 10 word problems to do, so ask me for that copy. They're all going to be addition problems. So you're just going to read what it says, just like what we figured out earlier with the gumdrop or the chocolate, the boxes that had the 3 chocolate drops. You're just going to add together. We're not doing any multiplying. You're just going to create 10 addition problems from these word questions and solve that, and that will be your homework for today. And now I'm sending you good luck vibes with your math homework. That's it for today.